1.
Let's get it.
On behalf of Ostrich
Okay, good. Did you have a question?
Can I give her a water bottle?
Yes. Okay. So, solving proportions. What's going to be really important is that you can identify the difference between the equations we've been doing over the last 2 class times and a proportion. Now, you can solve proportions exactly like I've taught in the other two classes, but it's not the easiest way, right? Proportions are much easier to be taught in a different way. A proportion, can somebody tell me what a proportion is? Jan.
Something that's like proportionate or like even, well balanced.
Okay, all right, I agree with that. Well balanced, proportionate, yeah.
Proportions or amounts to something?
Okay, yeah, like you have a proportion of this or that, right? What's the difference between a proportion and a ratio? Does anybody know? Because they often get used interchangeably, and they're not really technically the same thing. Yeah, John.
Okay, I'm taking a guess here, but our ratios are like something to something, like 5 to 3.
Okay.
Proportions like something that's like 3 to 3, or like even.
Okay, sort of. I mean, first of all, let's just talk about it. A ratio can be written in 3 different methods, right? You can have it, you could say 4 to 8, or you could say 4 to 8, colon 8, right? Or you could say like this, 4 over 8. Okay, so somebody's talking. I don't know who. Who is it? Okay. All right, let's have it quiet, please. So with ratios, you can write it in 3 different ways, okay? And you will see it in all these different methods. When you start to use it for math, always move it to this. So the first number you see goes upstairs. The second number you see goes downstairs, okay? So a ratio, well, let me just put it this way. Every fraction not only is a division problem, but it is also a ratio. Every fraction is a ratio. 1 to 2, 5 to 7. Those are ratios, right? So a fraction is a ratio. Now the difference between a ratio and a proportion is a proportion is a ratio equaling a ratio. Okay? That makes sense? So you have a fraction equaling a fraction. So you guys know what equivalent fractions are, right?
Yeah.
All right, so if I had 1/2 equaled 4/8, is that an appropriate proportion?
No. It's an equivalent fraction.
Yeah, it is.
As long as they truly are equal and they're equivalent, then yes, 1/2 is proportionate to 4/8, because I could simplify this and turn it back into 1/2, or I could multiply this by 4 and turn this into 4/8, right? So that is a proportion that is true. That is a true proportion. Had I done this, though, is that a possible proportion? No, that is not a true. That is not true. So you draw a line through it or something, and it's not equal to that. Yes.
I feel like I've learned proportions before.
Yeah, I think you have. My guess is everybody in here has, right?
I like
I
No.
feel like I have.
No?
I don't think I have.
ratios.
Oh, really? Okay. Okay, very cool.
I learned ratios
Alright.
and proportions.
All right, good to know. Good to know. I just assumed you guys would have known. But, so the difference, though. Okay, listen, guys. So the difference, though, is that, remember, this is algebra. And algebra is, James, this is algebra. And algebra is all about variables, right? You have an unknown. And so you're solving for an unknown. And so when you have a proportion, oftentimes it will look like, let me just write it. 11 over 6. Let's see, very simple. Okay, 9 over 2. 9 over 2. Here's our first one. 9 over 2 equals x over 12. Okay. So we've got, this is a proportion. And so the goal is to find out what is x. All right? Now there are different ways you can do it sometimes, but not always. But go ahead, Jan, what would you do?
I do 2x, so cross multiply.
Yes.
So the 2 and the x are 2x, and then equals.
So you're going to cross, let me just write this down, cross multiply. That is the easiest way to solve these, right? So you always do the one first that has the x in it. It's not really required, it's just that it's nice to have your x's on the left side of an equation, isn't it? Don't you prefer the x on the left? I do. So I like to do that one first. So 2 times x, it's not 2 plus x, it's 2 times. Your cross multiplying is equal to 9 times 12, which is 108, I think.
Yeah.
Okay? And then it's easy, right? It's a piece of cake, right? You divide by 2, and you got x is equal to 54, right? Okay, let's try another one. Let's say we had 11 over 6 equals x over 30. Here's another one. 11 over 6 equals x over 30. All right. So what would I do? Yeah.
Do you circle the 6 and the x?
Yep.
Yay.
So that is 6 times x, or 6x, right?
So it's 300.
Equals. That equals is really important. A lot of times I find kids totally get it during the lecture, and then they start doing it on their own, and they forget to put a plus sign. I mean, put an equal sign there. They put a plus sign instead or something, and then they don't know what to do. So it's got to be there. It's this times this equals this times this. Yes. Okay. So now I'm going to do 11 times 30. 330, right? And now I divide by 6. All right. Who knows what that is? Jan, quick. I don't know what it is.
55.
What is it?
55.
55? Is he right? Is he right? Yeah, that's right. That's right. Good job.
Gary, you
Well
should, you should live stream this stuff.
I know. I need Jan for all my
Wait, Gary.
videos where I do the
Yeah,
hard
Gary,
right?
I just did something different than what you're doing right now. So,
Hey, wait. Guys, listen up. Guys, listen up.
so what I did was I looked and I was like, 6 times what equals 30? Oh, 5. So I did 5 times 11 equals
Wait, hang
55.
on a second. Hang on. Let's just wait till everybody stops talking. Logan and Jan? Yeah. Dan. Go ahead.
So what I did is I thought 6 times what equals 30? So I said 5. So I was like, well then wouldn't it be 5 times 11? And I got 55.
And
but then you said 330 and I was like, wait, am I wrong? But then you ended up with
Dude,
so
that
it
was
a faster
excellent.
way.
So James noticed a pattern that as long as, if there is a number, you could multiply the denominator by of this denominator to get this denominator. Well, you could multiply the numerator times that number too. So 6 times 5 would be 30, so 11 times 5 is 55, right? So that's an easier way if it works. But if this had been 4, it wouldn't work, right? Because 4 doesn't go into 30. Actually, no, I don't think that. No, 2, yeah, 2 does.
It was not.
Okay, so now these are the easy ones, right? I'm gonna start throwing them make a little harder ones for you, and you're gonna see this. I like these better; they're more fun. Just have to find them in this book. Here we go. Okay, x plus 3.
Danielle,
This book is liking to do things with big numbers. I don't like this. Let's see, I could simplify that. Well, let's see, 8, 5, 5. Okay.
Gary, on the homework, is it all going to be even numbers or some of them going to be odd?
Yeah.
I don't know. Some will be odd. I don't know.
The way of the math.
I didn't figure that out. But x plus 3 over. So okay. I gotta take them, guys. I'm sorry. I've told you guys so many times. X plus 3 over 8 is equal to. Oh, I can't do that one. 510 over 16. All right, now in this one, you could use James's method, but
Yeah.
I'm not going to right now because a lot of times you can't. And so my style is to teach something that always works. Does that make sense?
Yeah.
Well, it can
James's
work
method-
sometimes. It's a
James's
shortcut
Dave's
for certain
method
ones.
sometimes works, and it happens to work on this one, but it won't work on all of them. So I want to focus on, doing it with the cross multiplication method. Jan.
Can I say what I would do?
So yeah, what would you do first?
Okay, what I think I would do
But-
is I would subtract 3.
Wait a minute, but 3 is busy being divided by 8, right? When you have x plus 3 over 8, what that really means is this. It's x over 8 plus 3 over 8 equals 10 over 16.
Ha.
That's
Oh.
what that means. Did you see that? That's being, 8 is dividing into both of those numbers. So,
Wait, no, don't erase it.
sorry,
Just
yes?
use this.
Yes, so I could rewrite it like that and use
Yes.
the method that we
Yes.
learned yesterday, right?
Yeah, can we do that?
Or let's just do cross multiply.
Yeah.
But when we do this, think of it like this. 8, yeah, that's right. So you can have 16, and you have to do parentheses. Do not do this in your head. Do not go, okay, that's 16x plus 3. Because it's not. It's 16 parentheses x plus 3. It is not 16x plus 3.
Gary,
Do you see the difference between the two?
such a difference.
This 16 is multiplying times the x, but it is not multiplying times the 3. This 16 is multiplying this times the 3, and that's what you want. It's 16 times all of this, right? You all see that?
I know you said we're not gonna do it, but could we write it the other way and then do that? Could we also do that?
Yeah, but I want you to practice
Yeah.
this method right
There's
now.
so many ways of doing it.
There's always many, many ways to solve problems, right? Always. Diego. Yes. And so what we're going to do is we're going to use a method called cross multiply, okay? And I noticed that I have x's here. If I did this cross, it's going to be the numerator times the denominator, right? And then equals the numerator times the denominator. But when I'm multiplying 16 times a binomial, this is called a binomial, where you have two terms. You have a one term and a second term,
Oh, no.
right?
Oh, no.
And so I have to multiply that 16 times both of those terms. That's why I put it in parentheses. So I've got 16 parentheses x plus 3 is equal to 8 times 10, which is 80.
Oh, yeah.
Okay? Now I'm going to use my distributive property, right? That gives me 16x plus
48.
48 equals 80. Okay? And now I've got, just in that one move, I now have an equation that's relatively easy to solve, right? I subtract 48 from both sides, and that gives me, I think, 32. Am I right?
16x equals 30.
And then I divide by 16, and x is equal to 2. Right? Does that make sense? All right, let's try another one. That was 3. Let's try 4.
Oh, yeah.
I'm trying to give you ones that are just going to work. This book is crazy. No, not that. Oh, with that. We'll just do one that's out of the book. You know what? Since some of these don't work out anyway, I'll just do one. X plus 4 over 3 is equal to 8 over 7. Okay? So sometimes they're not going to work out evenly, and I have no idea on this one. So we're going to, first of all, I see my x's are, if I did these, I get my x's on the left. So I'm going to do that first. So I do 7, and then I do parenthesis x plus 4 equals 3 times 8 is 24. Now I'm going to multiply using the distributive property. 7 times x is 7x plus 7 times 4 is 28
Whoa.
equals 24.
Whoa.
Now I'm going to subtract 28. That gives me 7x is equal to negative 4. Divide by 7, divide by 7. X is equal to negative 4 sevenths.
Wait.
Now, I think does that make sense? Do you guys get it?
I
It's pretty straightforward, really. It's pretty easy. They're pretty fun, actually. I don't remember when this class ends. Do you guys know?
It ends it ends when we want it to.
Wait, no.
11:40. So I have 10 minutes. We have 10 minutes.
The liar.
So
Wait, can we do our homework then?
very soon. Very soon. So
Sid, what do you?
I just want to clarify something. I could write this technically as negative 4 sevenths, or negative 4 over 7, or 4 over negative 7. Right? Those are all the same thing. Each fraction has one negative sign, therefore it is a negative fraction, right? Typically though, you would see it most often like this, or like this. Very seldom as a final answer would you put the negative in the denominator. Okay? The most common would be this. I'm sorry?
The 4 had negative, so I mean, it would normally it kind of make more sense if you started with those two, and doing that, it's kind of like.
Right. Now, okay, one last thing. I just want to be sure you guys can tell the difference between problems that are proportions and problems that are not. So, an example. Tell me which one this is. Actually, before I do that, let me do one last one. Let me do one last one. What if I gave you this? 3/4 x equals 6. So question, could you turn that into a proportion?
Yes, you can put the 1 under the 6.
I could put the 1 under the 6, but I have this x here. What do I do with that x?
Kill it.
You put the
What?
x next to the 3.
Why would I put it upstairs?
You would read it say x equals 8. Divide, so you would put
So, well, that x, remember when you're multiplying something times a non-fraction, it's really this, right? Am I right?
Yeah.
3/4 x is the same as 3/4 times x over 1. Therefore, x belongs upstairs with the numerator, right? So I could immediately rewrite this as 3x over 4 equals 6 over 1, and then I have my, the ability to use the cross multiply if I want.
Yeah.
All right, so now, tell me, what method would you use for this? 4/5 x plus 1/5 equals 3/5. What method would you use? Tell me your plan. Yes,
What you
James.
do is you'd multiply everything on the top by 5, and then you'd cross it all up. And then you
Awesome.
do 4x
Okay,
plus
that's all I
1
needed.
equals 3.
Yes, okay.
And then I solve it.
Good. All right. And Diego and Lila, don't worry because you haven't learned, you missed those. Don't worry about
That
that.
was fast.
Right? What is it?
He said x equals 2.
-2.
Wrong.
No,
Alright.
it's not. It's
No.
actually not.
X,
You are
I
wrong.
got
X-
4
No, I said
x
that's
equals
wrong.
2.
X
Yeah.
equals, X equals 1/2.
You're all wrong.
Yeah, 1/2.
Yeah.
1/2, right?
Yeah.
Yeah.
Okay, how about this? How about 2/3 x plus 4/5 equals 10? What method would you use?
4/5 x
What method?
plus 1/5
I know.
equals 3.
What method would you use
Gary.
for this one? I see one hand. I'm waiting to see more
Oh,
hands.
look at this hand, guys. You're jealous. Raise your hand. There you go, Lucas.
Okay, Lucas, tell me, what would you do?
So would you find a common denominator and then multiply everything on the top by that?
Yes. What would the common denominator be? Remember the trick? Does 3 go into 5?
No.
Does 3 go into 10?
No.
Does 3 go into 15?
Yes.
15. So you'd multiply everything times 15, times 15, times 15, and then you'll get your answer. You'll be able to solve it. All right, what if I gave you this? I gave you that?
Oh.
No.
Yeah.
Just give up.
No, I think I know.
Okay, Gardner.
It would be, you would have 4x divided by 9 equals 3 halves.
Okay, yes. So he rewrote it as 4x over 9 is equal to 3 halves. And now it's a proportion, right? And you would cross multiply, right? Okay, so fist to 5. You guys feel like you get this pretty clearly? Yes, no? I want to see it for everybody so I know. Fist to 5, fist to 5, fist to 5. Awesome. Okay, good. All right, I'm going to go ahead and put this